Okay, just like two more examples that I want to show you regarding the circuit. So there are two problems in the circuit that are particularly difficult. So I'm going to be giving you the answers to those now. This one right here is on the first page of the circuit. I think it's the second one down. And basically the idea is this is kind of a variation of an inverse sine derivative. Okay, so let's review up here real quick. The derivative of inverse sine is something that we did a long time ago. It's 1 over the square root of 1 minus u squared. U prime up here just means like derivative of baby. So the antiderivative is of 1 over or something over the square root of something minus a variable squared is going to be arc sine. It's a little bit more to the process when you're anti-deriving versus taking the derivative. So let me walk you through how that works. And the first thing you're going to do is in this formula here, you're going to identify what a squared is. And a squared is just going to be whatever the constant value is, so in this case 1, in your radical. So 1 is my a squared value. You're also going to just do one more thing with that, and you're going to square root both sides of that equation. So square rooting both sides would make this a, and then square root of 1 is still 1. Come back to that at the end. The second thing you're going to do is you're going to identify your u squared. So u squared would be all this stuff with the x. So u squared is equal to 4x squared. You are also going to antiderive this equation. So you're going to get u is equal to 2x, or sorry, square root this equation. So if you square root both sides, you get u is equal to 2x. This is the u that you're then going to use in your substitution, okay? So you're going to say u is 2x. What is the derivative of that? The derivative of that is 2. Multiply by dx, and you get du equals 2 dx, okay? Which means you have 1/2 du is equal to dx. Okay, so essentially I'm trying to find something to sub in for this guy here. All right, so let's see where we're at right now. We've got 1 over 1 minus 4x squared. We are calling u squared, and then dx is equal to 1/2 du. So there's the du, and there's the 1/2. Now you can antiderive. Again, antideriving, we already know that it's going to be arc sine. Here's the catch. The antiderivative is arc sine, but inside of that is u divided by a. U in this problem is 2x, a is 1. So you need 2x over 1 plus c. And then, of course, if you want to, you can, instead of 2x over 1, you could just call it 2x. And you're pretty much done. Keep in mind, arc sine is the same as inverse sine, so you could also write it like this. Actually, I think it is written this way on your circuit. That leads you to this problem in the circuit. And this problem, I think, is on the second page, second or third one down. So this is what the inverse derivative for inverse tangent looks like. It's, a number plus an x squared. That's kind of the setup we're looking at here. So we're going to go through the same process, and we're going to identify the a value, which remember is the constant on the bottom. So in this case, that is 4. We are going to square root both sides and say that means a would be 2. And then we're going to identify u squared. So u squared is x squared in this question. And that means that u would be equal to x if you square root both sides. And then you work from here. Okay, so this is your u. Take your derivative, multiply by dx, and you get du is equal to dx. Okay, so that means that du is equal to dx. Let's see what we've got. So we've got the antiderivative of 1 over 4 plus u squared du. Okay, now that means everything's in terms of u, so thumbs up that you can continue on. Here's your antiderivative. So your antiderivative is 1 over a, which is 1 over 2 arctan of u divided by a. U is equal to x, a is equal to 2, so that makes this x over 2 plus c.